All right, going further. So question 13, write a vector equation, parametric equations, and symmetric equations for a line. So the solution is from earlier videos. Vector, parametric, and symmetric equations of a line are shown. So here's vector equation of a line. And so if you have right here a line, this line L, and it has a point on it, a vector pointing on this point PO, x0, y0, z0, and that's going to be r0 vector. And then you have just any vector on with this point here, p, x, y, z. And you have a direction vector v. This is a direction vector parallel to this line. Like that. Then the vector equation of a line is equal to this point here. This is the vector with a point anywhere on it. Is equal to r naught vector plus a parameter t times by direction vector v. And I believe this a vector is just this t times v, like that. And this is just stating that this is just basically a multiple of this. So you're just a scalar multiplying this v, such that this is going to be equal to t times the vector. So this is direction, and then you scale it up. So for example, at this here we're going to have a large t. So this v is going to be extended out like that. So v vector like that, giving a direction, and then this is going to be t times v, etc. Anyways, so I'm just a bit messy here. Again, it's just a concept check review in case you've seen all the other videos. So make sure to watch those, and this is just a review of everything we covered. So parametric equations of a line, and to get the parametric equations, well, we would do the same thing with the starting the vector equation of a line. R equals r naught plus t parameter times v direction vector. And then what we would do is, well, this point right here, so this is a point on it. This is going to be x, y, z components. That's just r, just going to be x, y, z like that. But then you could separate these up into its components. So it's going to be x naught plus, this is going to be this right here, x naught, y naught, z naught, plus t times, and then this is the direction vector, and the direction vector has a, b, c components, and then times by parameter t. And then you can add up each component, so x naught plus ta, y naught plus tb, and z naught plus tc, and then separate these all into separate equations. So you'll have the x component is equal to x naught plus at, then the y is equal to y naught plus bt, z equals z naught plus ct, and these are the parametric equations of a line. Epic stuff. And then lastly, the symmetric equations, again, starting with the vector equation, r equals r naught plus tv. And the direction numbers are these. This is just direction numbers giving you the direction of the line. So v vector is equal to components has vectors a, b, and c. And then the symmetric equations is, well, we take these parametric equations, and then we just make t equal for all of them, just separate for t, and then equate them all. So in other words, move this here, so x minus x naught, and then divide this by a equals to t. Equals to t like that. And similarly, y, so move the y over, you're going to get y minus minus y naught divided by b is equal to t. And then similarly for z, z minus z naught divided by c is equal to t. And then t's all equate, so you get the symmetric equations of a line right here. So that's epic stuff there.